All right, here we are looking at section 7.1, and we're going to be starting to deal with polynomials. So our essential question for this section is how can you add and subtract polynomials? So let's look at our learning targets. First, we're going to find the degree of a monomial. Then we're going to be classifying polynomials. Our third learning target is add and subtract polynomials. Then finally, we're going to use these to solve some real-life problems. So usually we skip the explorations, but I want to talk to you a little bit about them for this section. So oftentimes when we're dealing with polynomials, it's easier to see them as things, right, as kind of algebra tiles. So here's what we're looking for. So the first thing is we're going to write the expression modeled in each step. So I see I have 3 of these green long ones. These are considered our x tiles. So here I have 3x, and I have plus 2, just 2 yellow ones. And I'm adding to that 1x, but then I have 5 negatives, so I'm going to have my x minus 5. So then I can combine my like terms, right? So now I have 4 green ones. I see that I have 2 yellow ones and then 5 red ones. Well, I know that a yellow one and a red one kind of cancel each other out because this is a positive one and this red one is a negative one, and a positive one plus a negative one gets me back to 0. So those go away. So here's what I'm left with. So once I've done this and I've come out with 4x minus 3, because that's the tiles that I'm left with. So I can see that as well in here. So here I see this blue tile. This is going to be an x squared, as evidenced here, right? X squared. I have 2 x's and I have 2. So that's worth my 2x plus 2. And I'm subtracting a positive x and a negative 1. Right? So in order to combine my like terms, this sign right here has to be a positive. So I have to switch the color of both of these tiles. Whereas if we're doing this mathematically, right, I can't just subtract the x. I have to have my x squared stays the same, my 2x stays the same, my 2 stays the same. But then this, I minus x, and then I multiply this times negative 1, so it would be plus 1. So then I can simplify and add my final terms together. So just think about different tiles occasionally when we're doing this. And it's best to think about this because I can see that an x squared and an x are very different things, right? This blue tile and this green tile are very different sizes and shapes. So I can't combine them. They're different kinds of things. So now let's talk about a degree of a monomial. So the degree is the sum of the exponents of the variables. So a monomial, right, is a thing with one term. Mono meaning one. So these are different monomials, right? They have one single term. And this tells me my degree. So if it's just a constant, right, nothing with the variable, it has a degree of 0 because I'm only talking variables. So I look at all of my exponents of all of the variables that I have and I add them together, and that is the degree that I'm looking for. If I'm dealing with negative exponents, those are not considered monomials, right? Because it will change how we look at those and it will become a fraction. So here's some examples of monomials and the degree that they are. So again, we're just looking at the variable and the exponents. So let's look at example number 1. So I'm supposed to find the degree of each monomial. So in part A, I see that I have one variable and it has one exponent. So my degree for this one would be 2. So let's look at part B. So here's my monomial, right, because it's one big term. I see that I have an x and a y cubed. Well, I know that the exponent with x is a 1, even though it's not written there, and the y has a 3, so I'm going to add these together. So 3 plus 1 is 4. The degree of this monomial would be 4. So let's look at part C. Again, I can add all of my exponents together, so 3 plus 3 is 6. So let's look at D. D, remember, is a constant. I don't have any variables, right? There's no letters to it. So I know that the degree there is 0. So here's some monitoring progress. Go ahead and try these ones. So here's our big core concept, a polynomial, right? We've looked at monomials as just one term. So polynomial is several terms together. Okay? So a polynomial with 2 terms, right, is a binomial. Think about bicycle has 2 wheels, so there are 2 terms. And a trinomial has 3 terms, right? Think of tricycle has 3 wheels, and a trinomial has 3 wheels. So the degree of that polynomial is the highest exponent, right? Is the greatest degree of its terms. So remember, back we found the degree of a monomial. So we're going to find the degree of each term in my polynomial, and then the degree of that polynomial is the highest one. Okay, so when we always want to look at things in standard form, and in standard form means my variables are in order of the biggest to the smallest exponent. So you'll see this example is in standard form because my highest exponent, which is 3, goes first, and then 2, and then 1, and then I don't have an exponent. Okay, so that's standard form. So the degree would be the highest exponent. The leading coefficient is the number, right? The coefficient, remember coefficients are numbers, the number with that variable that has the highest exponent and it has the highest term, okay? So that's my leading coefficient. The degree is the highest degree out of all of my terms, and then I always want to go in order in standard form. Okay, so now let's look at this. I'm supposed to write this in standard form, then identify the degree and leading coefficient of the polynomial. So I know that I want to do the highest exponent first. So I look and I see that this would be a 1. I have a 3, and then I don't have any. So this term would definitely go first. And that negative is in front of it, so the negative has to stay with it. So that term goes first. Then I have my 15x, and then I have my constant, or my 3. Okay, so now I have to look and see what the degree is and the leading coefficient. So the degree is going to be the largest exponent. So my degree is going to be 3. Then my leading coefficient, right, is the number that's with it. So it's going to be a -1. Since there's nothing with this x, I know that it's going to be a -1. So my leading coefficient is -1. The degree is 3, and I've written this in standard form. So now here is example number 3 that we're going to be looking at. Here we're going to write each polynomial in standard form, and then identify the degree, and then classify it by the number of terms. So let's look at A. So A only has one term, so it already is in standard form. Okay, so the degree of this would be the highest exponent, so it's a 4th degree, and there's only one term, so it's going to be a monomial. So it's a 4th degree monomial. And mono, remember, meaning 1, because there's one term there. So now let's look at B. So I have to first put it into standard form. So I find my highest exponent first, which is this 5x squared. Then my next highest exponent is that -x. And then my constant term is a 4. So now I can find the degree, which is the highest exponent. So it's a 2nd degree. And there are 3 terms, so this is a trinomial. So now let's look at part C. First putting it in standard form, finding the highest, so it's that q to the 5th plus 8q, right, because highest exponent to lowest. And then my degree would be that highest, so this would be a 5th degree. And I see I have 2 terms, so it's a binomial. So here are your next monitoring progress. Check these out and try them. So here we're going to starting to be finding the sum and difference, right? We're going to be adding and subtracting. So find the sum. This is example number 4. So let's look at part A. I've got my 2x cubed minus 5x squared plus x plus the quantity 2x squared plus x cubed minus 1. So the first thing I want to do is I want to get all the terms in order in rows so that I can add them. So I'm going to leave this first term where it's at and then move the pieces of the second term so they fit in. So I see I have a 2x squared, so I'm going to put it underneath the other x squared. I see I have an x cubed, so it's going to go with my other x cubed, and then I have a -1. So that -1 comes out here because in my first equation I would be plus 0 would be my constant. So now that things are in order, now I can go ahead and add them up. So I know that 0 plus a -1 is -1. X plus 0 is x. Negative 5x squared plus 2x squared is a -3x squared. And then 2x cubed plus x cubed is 3x cubed. So here's my final answer. So now let's look at B. There's another way I can do this. I can also group the similar terms, right? And I can do that because I'm adding. If I'm subtracting, we'll talk about what we have to do first. But because I'm adding, I can group my terms. So I'm going to start with the first term of the first polynomial. Okay, so I see that it's a squared, so I'm going to find any squares in my second part. So I'm going to add x squared, right? Those have similar degrees. They're the same degree, same base. Then I see I have plus x, and then in the second one I have 4x. Now I'm dealing with my constants, negative 6 plus 10. So now that I've grouped like terms, I can go ahead and simplify. So 3x squared plus x squared is 4x squared. X plus 4x is 5x. Negative 6 plus 10 is 4. So I can do this by either organizing them, lining them up in columns, or I can just combine like terms and go from there. Okay, so now this is example number 5. Now we're finding the difference, right? So we're subtracting. So I can't go ahead and combine my terms yet. I have to get rid of the subtraction sign. So in order to do that, I'm going to distribute that to the entire second polynomial. So I start off by writing my first polynomial just exactly how it's written, and then I distribute this. So I have a negative times a negative 2n, right? This now becomes positive. This becomes positive, 2n squared. Negative times a positive 2n, and a negative times a negative 4. So I've changed the sign on every single term in my second polynomial. Now that I have this addition in between, now I can combine terms, or I can go back and line them up in columns if that's how I prefer, and add them together. So I see I have 4n squared, and I have a 2n squared. So I've taken care of that one, and I've taken care of that one. I have a negative 2n, right? I don't have an n term in this first polynomial, and that's okay. And then I have 5 plus 4. So now I can simplify. 4n squared plus 2n squared is 6n squared, plus a negative 2n plus 9. It's helpful to think of these n squareds and each base as a thing, right? Back when we were looking at our algebra tiles, this thing right here would be our x squared. So when I'm adding them together, it's like I have 6 blue tiles, and that blue tile is an x squared. So I don't actually change anything with those at all. Oh, we're past that one. Here we go. So like here, it's not going to be 4n squared plus 2n squared equals 6n to the 4th or anything. An n squared is a thing, so I can just add up how many things I have. So now let's try part B. So again, I write my first equation exactly as it is, my first polynomial, and then I have to change my sign to addition, and in order to do that I have to change the sign of everything that follows it. So since this 3x squared was positive, it now becomes negative. This x was negative, it becomes positive, and this 8 was negative, so it becomes positive. So now I can go ahead and combine my like terms and add. So I have my x squareds that are taken care of. Now I'm going to deal with my x's, right? I've got a negative 3x and an x, and then I've got a 5 and an 8. And those are my constants that are taken care of. So now I can just go ahead and add. 4x squared minus 3x squared is just 1x squared. Negative 3x plus x is a negative 2x. 5 plus 8 is going to be 13. So now I've gone ahead and I've subtracted both of these examples. So now here's your next monitoring progress. Try these. So try some addition and some subtraction to make sure that you can do both of them. So now here's our real world problem. Right? So a penny is thrown straight down from a height of 200 feet. At the same time, a paintbrush is dropped from a height of 100 feet. The polynomials represent the heights in feet of the objects after t seconds, right? So here's my penny that's thrown, and here's the paintbrush that's thrown. And you'll see a couple of differences here. So now I'm supposed to write a polynomial that represents the distance between the penny and the paintbrush after t seconds. So I know that I'm going to have to subtract my polynomials, right? Because I'm finding the difference here. And whenever you see a difference, that's subtraction. So I'm going to go ahead and write my equation. So I take my first one, my paintbrush, which was negative 16t squared minus 40t plus 200, and I'm going to subtract that negative 16t squared, I didn't have a t term, plus 100. Okay, so when I'm subtracting like this, I can do it either in columns or like we've done on previous slides. It doesn't matter. When I have to make this a plus, I have to change all of the signs in here, so that becomes a plus, and this becomes a minus. So now I have negative 16t squared plus 16t squared. That goes away, because a negative plus a positive of the same amount gets us to 0. Negative 40 minus 0 is negative 40t. 200 minus 100 is 100. So here is the difference, the distance between the two objects, right? So now I'm supposed to interpret the coefficients of the polynomial in part A. So coefficients, remember, are the terms, are the numbers that we're looking at. So the easiest way to kind of interpret, and right, when we interpret, we're looking at in the context of the problem, is to come up with a couple of scenarios that we're talking about. So when t is 0, right, that means that's right when I drop them. Let's see what happens. So I'm going to go ahead and put t in for 0, right? So I've got negative 40 times 0 plus 100. Anything times 0 is 0. So this means that when t is 0, right when I originally drop both objects, they are 100 feet apart. Okay, so then let's try a t of 1. And try this again. 40 times 1 plus 100. Negative 40 plus 100 gives me a negative, or a positive 60. So the difference here, right, is I'm now only 60 feet apart. So that tells me for every second that the objects fall, they get 40 feet closer. So that's what those numbers tell me. So here's the original distance, right? Originally, when I first start, they are 100 feet apart, and then every second they get 40 feet closer together. So that's how we can use the context of the problem to explain the terms that we're looking at. Okay, so here's your final monitoring progress. So try it. These word problems, I know these are tough word problems, but these are the ones that are really going to show if you know your stuff before you try and take the quizzes and exams. So let's look back at our learning targets real fast. Our first one was finding the degree of a monomial, right? And that's what we're really dealing with here, is looking at one term and how many exponents we have with the variables that we're looking at. Then we're going to be classifying polynomials. The real classifications we're looking at is we're going to try and figure out which degree the polynomial is, and then what kind of polynomial is. Is it a monomial, meaning it has one term? Is it a binomial, meaning it has two terms? Or is it a trinomial, meaning it has three terms? Those are our big three classifications. Our third learning target was add and subtract polynomials. Just the biggest difference there, remember, was in order to subtract, I want to get rid of that subtraction sign and turn it into an addition of the opposite. That's how we can do this with polynomials. And then our final learning target was to solve real-life problems. Make sure you go and do that monitoring progress on this one so you can be sure that you can do this and think these things through. Now it is time for you to go ahead and start working on your homework for section 7.1.